Hello guys, today I'm going to explain you the basic concepts of GraphQL and I'm going to show you a small demo of how to set up a GraphQL API using ApolloServer and Node. But what is GraphQL and why should we even care? GraphQL is just a query language for exchanging data between client and the server. It is built upon a HTTP protocol. When using GraphQL API, you control what you are exactly fetching. In REST APIs, you are always receiving the whole model, even if you only need a part of it. In GraphQL, you as a client decide what to fetch. If you need data from two separate models, no problem, you can fetch them in one query. GraphQL optimizes data exchange over the network. So with that knowledge, we are ready to jump right into the code. In my code editor, I have opened an empty project. There is only one JSON file. I have added it to mock database. We will be focused on GraphQL, not on the implementation of SQL queries. The movies JSON file consists of two main schemas. At the top, we have a list of movies genres. Beneath that, we have a long list of movies. The single movie contains pieces of information such as AD, title, year, runtime, genres, plot, director, actress, or poster URL. Okay, we will start with the initialization of the Node project. For this demo, I will use two packages, ApolloServer and NodeJs. ApolloServer is one of the implementations of GraphQL standard for servers. In my opinion, is one of the best. It has a wide community, great documentation, and a built-in client for testing API. Besides these packages, we need a file to work with, so I will create one. Firstly, I will import genres and movies from our JSON file, just to have them prepared to use. Next, we will need two imports from ApolloServer package. We need an ApolloServer class and GQL method from that package. GQL is a helper method for defining the GraphQL schema. You can think of a GraphQL schema as of database schema. We as programmers define them to describe what our model look like. Then the client can freely query them without any restrictions. But schema itself is not at all. To have a fully functional API, we need to create resolvers. In other words, we have to tell ApolloServer how to fetch or update a specific model from our system. We will be talking about resolvers later. Let's focus on schema first. I will name the variable for my schema type defs. It's a naming convention for that. Then I will invoke the GQL method. Here I'm passing the JavaScript string literal. We have to use a type keyword to define a type and just name it. In the curly braces, we define our types properties. They might be scalars, enums, or object types. Our movie type has an ID property, which may be defined as a GraphQL ID type. GraphQL IDs are serialized strings that uniquely identifies the objects. Next, we have a title field, which is a string, year property of integer type, runtime, let's set it as a float, genres, it's an array of strings. Finally, we will add a string type plot. It is worth mentioning that in GraphQL all properties by default are treated as optionals. There are a few reserved keywords for GraphQL schemas, and one of them is a query. A query is an object containing all possible actions related to data fetching. Let's say we want to fetch all movies, so we have to define some queries which will allow for that. So here, inside the query type, let's define a custom query called getMovies. Its return type is a list of movies. What we have done until now is just a simple schema definition. As I mentioned before, the schema is only one part of the puzzle. We have to tell GraphQL how to resolve our queries. For that, let's create a resolver object and name it just resolvers. Resolver object have to map our schema queries to some data. So here we're creating a query object with a getMovies method. The names inside resolvers and schema must match, otherwise this won't work. Our getMovies method will return movies from our JSON file. Normally, here we would have to call to database or another API. It's just for simplicity, we're returning mocked data. With typedefs and resolvers set, we are finally ready to start our server. For that, we have to pass typedefs and resolvers to ApolloServer constructor. Now we can call listenTo method on our server instance and then method to extract the server URL and create a log message. We didn't pass any configuration to the server, so it will be running on the default 4000 port. Let's open up the terminal and type the command to start the server. Here I'm using the NodeDaemon. This package will automatically restart the server when we update the script. Let's copy the URL and open it in the browser. As you may see, we are presented the ApolloServer initial page. This page does not contain any useful information. Just check automatically redirect to the studio next time and click Query your server. After a few seconds, we will see Apollo Studio page. At the top of the page, next to the sandbox button, we can see URL pointing to our local host. Apollo has filled this for us, so we can query our server. In the left panel, we can see documentation of our API. For queries, we only defined one, called getMovies. We can expand the list of fields by clicking on the query name. Next to the query name, there is a big plus button. When we click it, it adds the query to our example query. The example query is a client name for grouping other subqueries. It could be anything. We will leave the name example query as it is. Here, the name getMovies must match the name from the backend. Okay, but now we only have an empty query. To fetch actual data, we have to add the fields we need. We can type the names of the fields, or again use the buttons from the left side menu. We have defined the 5 fields on our movie model. But imagine that our frontend only needs 3 of them. Normally, if we use the REST API, we will overfetch. It means we will fetch unnecessary data. With GraphQL, we can avoid that. Let's put only ID, title, and year inside curly braces. And let's execute this query. As you can see, we have only fetched the data we wanted to. That's great, but to see the true power of GraphQL, let's move back to the code editor and add more queries. Imagine that in our client app we have a list of movies. We could potentially add the filtering feature. We could filter by a genre. To do that, we need a filter of all genres. In our mock JSON, we have a list of genres. It's a simple list of strings. Inside our schema, in query type, we will add another query. I will call it getAllGenres, and I will set the return type to the list of strings. In resolvers object, I will add another function. It will be just returning the mocked genres. When we move back to Apollo Studio and refresh the queries, we will see our new query added. Click plus button and Apollo append it to our example query. Now we can fetch data from 2 sources in one single operation. Here we don't have to specify what to fetch because getAllGenres returns a list of strings, not objects. So the same name is just sufficient. When we execute our combined query, we got data from both getQueries and getAllGenres. To verify that, let's scroll down to the result page. As you can see, at the very bottom of the page, we have our genres returned. Okay, for now it's enough about querying and fetching. It would be good to know how to create or update some data. In GraphQL, there is no difference in syntax between creating or updating data. For that, we use mutations. It's really easy to remember. When we fetch data, we use queries, otherwise we always use mutations. So let's create one mutation for creating a new movie. The mutation, same as the query, is a reserved keyword. The mutation is our wrapper for all updating entities actions. Inside mutation, I will declare a createMovie function, and I will set its return type to be movie. In contrast to queries, we have to specify the input for our mutation. It is done here inside the parentheses. I will just copy-paste the data from movie model. Now we have to add mutation to our resolvers. Our mutation function takes 4 arguments. Currently, we are interested only in the second one, which is our input. Let's omit the rest of them. We will discuss them deeply in another tutorial. We can start implementing our createMovie function from generating a new ID for our movie. For that, we will find the last movie, get its ID, and increment it by 1. Oh, I see that I have copied too much from the movie model in our mutation. We don't want to have ID passed by the user. Now we can create our new movie object, push it to movies array, and finally return it to the user. Okay, let's move back to Apollo Studio and test it out. When we navigate back from queries, we should see a mutation type. When we click it, there is our createMovie mutation present. We can add it to editor by clicking the plus button. Now we have a mutation to work with, but it's missing the input fields. Again, we can add them just by selecting them from the left menu. As you can see, variables are added to our mutation. Variables must start with a $sign. We can set values of variables in the very bottom menu. But there is still one part missing. When updating the data, we still have to specify what data we want to be returned from GraphQL server. I will pick a few of them. Then I will set some values of our variables. Now I can execute our query. Great! We have successfully created new movie. As you can see, it's returned from our API. So that's all for today. I hope you get it useful. See you next time.